friends, hello. Today we will discuss about relational algebra. We start our discussion with what is relational algebra. Relational algebra is a high level procedural language that is derived from mathematical set of theory. Here procedural means it uses some procedures or say algorithm to execute any operation, and mathematical set theory specifies that it uses the concept of sets of mathematics to carry out tasks. It consists of a set of operations that are used to produce a new relation from one or more existing relations in a database. Each operation takes one or more relations as input and produces a new relation as output, which can be used further as input to another operation. This allows expressions to be nested in a relational algebra. There are 5 fundamental operations of relational algebra named selection, projection, Cartesian product, union and set difference. The first 2 operations, selection and projection, are unary operations, means they operate on single relations, whereas the last 3 are binary operations, that is they operate on 2 relations. In addition to these 5 basic operations, there are some derived operations of relational algebra, which can be represented in terms of the 5 fundamental operations like join, intersection and division. We will be discussing every operation one by one shortly. So, first operation is selection operation. The selection operation operates on single relation and is used to select those tuples of the relation to make a subset of relation that satisfies a given condition. This operation can be considered as a filter that is used to keep only those tuples that satisfies the given condition. It is denoted by the symbol sigma as shown, and the condition appears as its subscript. The condition can be simple or complex. So, complex conditions can be represented by using the logical connectors and, or and note. The comparison operators that are used in the selection operation are less than, greater than, equal to, not equals to, less than or equals to and greater than or equals to. Generally, selection operation is denoted by the expression shown on the screen. Here the symbol sigma is used to denote the selection operation, and the selection condition is a Boolean expression specified on the attributes of relation R. The resulting relation from the selection operation has the same attributes as capital R, or we say relation. Let us take an example. Look at this table. This table represents the books relation. So, to select those tuples from the books table where subject has the value database, we write the operation as shown onto the screen. The output of this operation will be those tuples of relation books where subject is database as shown. Now, this operation has given us a new relation after extracting some of the tuples from books relation satisfying the condition mentioned in the selection operation. The selection operator can be used in complex ways as well by combining logical operators greater than, less than, etc. with logical connectors and, or not. For example, look at books relation again. To select those tuples from books relation where subject is database and price is 450, we write the operation as shown onto the screen. Now, the output of this relation is those tuples where subject is database and price is 450, and the AND operator will select only those tuples that satisfy both the conditions. Like this, OR operator will select the tuples if either of the condition is true, and the NOT operator will select tuples if the condition is false. That is, if condition is false, then NOT condition is true, otherwise it will not select any tuple. Let us take one more example. So, look at this select operation that we have shown. Now, this operation will select only those tuples from books relation where subject is database and price is less than 450 or the publication year is greater than 2010, that is, books are published after 2010 as shown in the given table. So, that is how selection operation can be used to select tuples from a relation based on some conditions in some particular manner. So, second operation in relational algebra is projection. Projection is like the selection operator. Projection operator also operates on single relation. It is denoted by using symbol pi as shown onto the screen. The difference between two is that the selection operator operates on tuples, means rows, while the projection operator operates on attributes, that is the columns of the relation. If we are interested in only in some selected attributes of a relation, we use the projection operation to project the relation over these attributes only. So, look at the syntax of the projection operation, where pi is the symbol used to represent the projection operation, and angle bracket attribute list angle bracket close is a list of attributes to be selected from all the attributes of the relation capital R. The result of the projection operation is only the attributes specified in the attribute list, and attributes are in the same order as they appear in the list. Hence, its degree is equal to the number of attributes in the attribute list. Let us see an example. Let us reconsider the relation books. If we are interested only in subject attribute, its author and price, then we can use the projection operation as shown onto the screen, and it will result in a new relation which will be a subset of books relation as it is shown. So, next operator is Cartesian product. The Cartesian product operation is a binary operation, that is, it operates on two relations and it is denoted by the symbol cross or X, we can say. It is sometimes called cross product or cross join. The Cartesian product of two relations R and S is denoted by R cross S, and it defines a new relation which is the concatenation, or we can say combination of each tuple of relation R with each tuple of relation S. Suppose if the relation R has n attributes and the relation S has m attributes, then there should be n plus m attributes in the resultant relation. For example, here we have two relations named EMP for the employees with 3 attributes, namely E number, E name and salary, and another relation is DPT for the department with 2 attributes, D number and D name as shown. So, the Cartesian product of relation EMP and DPT denoted by EMP Cartesian product DPT will be as shown onto the screen, and it is clear from here that it has 5 attributes, 3 taken from the EMP relation and 2 taken from the DPT relation. So, next operator is union. The union operation is a binary operation and it is denoted by the symbol as it is shown. The union operation of two relations R and S select all the tuples that are in R or in S or in both of the relations, but eliminating the duplicate tuples. Hence, R and S must be union compatible. So, when the two relations are said to be union compatible? If they have the same number of attributes, if each pair of the corresponding attributes has the same domain. For example, consider two relations EMP underscore L, that is for employees of the legal department, and EMP underscore M for the employees of marketing department. The union of the relation EMP underscore L and EMP underscore M is denoted by EMP underscore L union EMP underscore M will be shown onto the screen. Here duplicate tuples to Firoz has been automatically eliminated and rest is the union of two relations. Next operation is set difference. The set difference operation denoted by the symbol minus defines a new relation that consists of the tuples that are in one relation, but not in another. That is, suppose we apply the set difference operation on two relations R and S denoted by R minus S. Then the resulting relation will consist of tuples that are in capital R, but not in capital S. Hence, both the relations must be union compatible. And it must be noted that R minus S is not same as that of S minus R. This operation allows deletion of tuples from a relation. So, let us look at an example. Reconsider the previous two relations EMP underscore L and EMP underscore M. Now, if we apply set difference operation on EMP underscore L and EMP underscore M, then the resulting relation will be. So, we move to the next operation, that is intersection. The intersection operation is a binary operation. It is denoted by the symbol shown. It intersects two relations and returns a new relation with the tuples that are in both the relations. In this, both relations must be union compatible. Intersection of two relations R and S denoted by R intersection S defines a new relation consisting of the set of tuples that are in both R and S, hence both the relations must be union compatible. Let us explore an example. Reconsider the two relations EMP underscore L and EMP underscore M. The intersection of these two will result in this relation. Here the tuple 2 comma Firoz is present in both the relations and hence it is our result. So, now let us continue with the next topic, joins. The join operation is used to combine related tuples from two relations into single tuple. This operation is very important for any relational database because it allows us to process relationships among relations. The join operation is derived from the Cartesian product operation of relational algebra. We can say join operation is a combination of selection, projection and Cartesian product. There are various forms of join operation such as theta join, equi-join, natural join, outer join and semi-join. The outer join operation is further classified into left outer join, right outer join and full outer join. Let us continue our discussion one by one. First is theta join. This is the most common type of join. It is denoted by the symbol theta. The theta join operation of two relations defines a relation that contains tuples satisfying a join condition from the Cartesian product of two relations. This join is sometimes called conditional join. The join condition is defined as R dot A1 theta S dot B1, where theta may be one of the comparison operations, less than, greater than, equal to, not equal to, less than equal to and greater than equal to. And here R and S are the relations and A1 and B1 are the attributes respectively. In terms of selection and Cartesian product operations, the theta join operation can be represented as shown. For example, let us take two relations of students named S1 and S2. S1 with attributes student ID dot 1, S name, rating and age, and the relation S2 with attributes student ID dot 2, BID and day as shown. And let theta join operation be. Look at the resulting relation. Now, next operation is equi-join. Equi-join is same as theta join, except that in this we can use only equal to operator as the comparison operator. No other operator can be used in equi-join. Its syntax will be as shown. Let us reconsider the previous two relations S1 and S2 as our examples. Equi-join on these two will be performed by this equation as, look at the resulting relation. Here student ID 1 and student ID 2 of S1 and S2 respectively are equal. Now we come to natural join. It is an equi-join operation. It is denoted by the symbol shown. In this, the two join attributes of both relations should have the same name in both the relations. The result of the natural join is the set of all combination of tuples in both the relations that are equal on their common attribute names. For example, we have two relations. One is student with attributes ID, name and city, and other relation is enroll with attributes ID and course. Their natural join denoted by student natural join enroll will result as. So, next is outer join. Usually in join only those tuples from two relations are selected which satisfies some condition, but in outer join the tuples that do not satisfy the join condition also appears in the resultant relation. This adding up of tuples is called dangling, and this dangling tuples are padded up by special null symbol in the result. This outer join is of three types as we have already mentioned. So, we start with the left outer join. The left outer join operation on two relations R and S selects unmatched tuples from the relation R along with the matched tuples from both of the relations R and S that satisfy the join condition. Missing values in relation S are set to null. For example, consider two relations employee and department. The resultant relation of left outer join on these two relations will be. So, here tuple Umesh 5617 sales of employee relation has no match in the department relation for department name field. So, while it is added, but set to null for the manager field. Next outer join is right outer join. The right outer join operation of two relations R and S selects unmatched tuples from the relation S along with the matched tuples from both the relations R and S that satisfies the join condition. Here missing values in the relation R are set to null. For example, reconsidering the employee and department relations, and the resultant right outer join relation will be. So, here the tuple production comma Lakshman of department relation has no match in employee relation for the department name field. So, while it is added, but set to null for the name and ID fields. Full outer join. In full outer join operation, unmatched tuples from both the relations R and S appear in the resultant relation along with the matched tuples. For example, reconsidering employee and department relations. The resultant full order relation for the join operation will be. Here unmatched tuples from both of the relations are included with null for unmatched fields. Now, we come to the last category of join operator, that is the semi join. The semi join operation on two relations R and S defines a new relation that contains the tuples of relation R that participate in the join of R with S. Hence, only the attributes of relation R are projected in the resultant relation. The advantage of semi-join operation is that it decreases the number of tuples that are required to be handled to form the join. The semi-join operation is very useful for performing join operations in distributed databases. Again, reconsider the previous two relations, employee and department, and their semi-join operation will result in here tuples only from relation employee is taken. So, the last operation of relational algebra is division. The division operator is a binary operation. It is denoted by the symbol division. The division operation on two relations R and S defines a relation consists of the set of tuples from R that matches the combination of every tuple in S. So, let us discuss it with an example. Consider two relations, subject with attributes name and course, and another relation is course with attribute course. Then after performing division operation, the resultant relation will be here. In this resultant relation, only tuple consisting field database from relation subject is taken and all other tuples are eliminated as they do not match with every tuple of relation course. With this, we come to an end of today's lecture. Today, we have discussed about the relational algebra. So, in the next lecture, we will learn about SQL queries. Thank you.